Hello, hi, bro. Hi, Sumaya. I'm good. Blaze, hi. So, electric current. Electric current is nothing but today topic. We are going to discuss about electric current. Electric current. CBSE Grade-10 Physics. CBSE Grade-10 Physics. CBSE Grade-10 Physics. The rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge. Rate of flow of charge. Yes. So today I'm going to start from beginning of the chapter. Rate of flow of charge. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. Right. So rate of flow of charge is called electric current. Rate of flow of charge. So I'm taking I equal to Q by T. I equal to Q by T. So the rate of flow of charge. Rate of flow of charge I equal to Q by T I am considering. SI unit of charge is SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. Coulomb. SI unit of time is second. SI unit of time is second. The rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. Electric current. Electric current. Yes or no? Rate of flow of charge is called electric current. So I am considering here. So here now 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge. 1 coulomb of charge. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. Electric current. Okay. So I'm considering here there are positive charges and negative charges will be there. There are positive charges and negative charges. There are positive charges and negative charge. So there are charges are moving inside of the conductor. 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 So charges are moving inside of the conductor. Charges are moving inside of the conductor. So you can consider. So charges, see, positive charges are there, negative charges are there, positive charges are there, negative charges are there, positive charges are there, negative charges are there. That's why charges are moving inside of the conductor. Charges are moving inside of the conductor. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere equal to 1 coulomb of charge flowing through unit cross section area per second is called electric current. Okay, so now we can take Q equal to quantization of charge plus or minus Ne. So quantization of charge is plus or minus Ne. Quantization of charge is plus or minus Ne. That is Q equal to plus or minus Ne. Charges are moving inside of the conductor. Charges are moving inside of the conductor. That's why Q equal to plus or minus. Q equal to plus or minus Ne. Q equal to plus or minus Ne. Q equal to plus or minus Ne. On one electron, 1.6 into 10 power minus 19 coulomb. On one electron 1.6 into 10 power minus 19 coulomb of charge is present. On one electron, on one electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb how many electrons are present? So 1 coulomb equal to 1 by 1.6 into 10 power minus 19. So if you are taking 1 by 1.6 into 10 by 10, then you will get 10 power 19. So 10 by 16 into 10 power 19. So you'll get so 10 by 16 values, 10 by 16 values, 10 by 16 values 0.625 into 10 power 19. That is 1 coulomb. So in 1 coulomb, so here in 1 coulomb, if you are taking 6.25 into 10 power 18 electrons are present. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Once again, so the rate of flow of charge. So once again, so current is defined as, so the rate of flow of charge. Rate means with respect to time. With respect to time, I am taking with respect to time. So rate of flow of charge. Rate of flow of charge. I equal to Q by T. I equal to Q by T. So the rate of flow of charge. Rate means with respect to time, I am taking with respect to time. With respect to time. With respect to time. So with respect to time I am taking, so I equal to Q by T. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So I equal to Q by T, 1 ampere, SI unit of current is ampere, SI unit of current is ampere. Okay. So here I am considering SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. So 1 ampere equal to 1 coulomb per 1 second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So charges are moving inside of the conductor. Charges are moving inside of the conductor. There are many charges I am taking. Okay, number. So number. That's why the charge is integral multiple. So that's why Q equal to plus or minus Ne. So there are many charges will move inside of the conductor. If it is only 1 or 2, if only 1 or 2 it goes, we can't say current is flowing. So we can take, so number of electrons, number of charges are moving inside of the conductor. Number of charges, that is why we are taking plus or minus. See, why we are taking plus or minus, so positive charges are moving, negative charges also moving inside of the conductor. That's why we are taking plus or minus. So N is the integral multiple of charges. I'm taking. So Q equal to plus or minus Ne. On 1 electron 1.6 into 10 power minus 19 coulomb. So in 1 coulomb 1 by 1.6 into 10 power minus 19. 1 by 1.6 into 10 by 10. So you'll get 10 power 19. So if this 10 power by 19 it goes up, 10 power 19 goes up, we can take 10 power 19 goes up, we'll get 10 power 19 plus. So here normally if you are taking 1 by x power minus 1, so x will get 1 by x power minus 2 will get x power 2. So 1 by x power minus 3 if you are taking x power 3. Okay, so like that we can consider if it is goes numerator, we'll get it. Okay, so here also same thing. So here 10 power minus 19 is there, if it is goes up 10 power plus 19 will get. Okay, so like that we can consider. And one more point here in one column 1 points. So in one column, if you are taking one column 1 by 1.6 into 10 power minus 19, 1 by 1.6 into 10 by 10 into 10 by 9, 10 power 19. So 10 by 16 if you are taking 10 power 19. So 10 by 16 if you get 10 by 16. So 10 by 16 if you are taking 10 power 19. So 10 by 16 is 0.625, 0.625, 0.625, that is 10 power 19. So in one column 6.25 into 10 power 18 electrons are present. 10 power 18 electrons are present. So this is about electric current. Electric current, and on one electron how much charge is present, in one coulomb how many electrons are present, on one electron 1.6 into 10 power minus 19. So in one coulomb 6.25 into 10 power 18 electrons are present. So very important. So this is about electric current. Electric current on one electron how much charge is present. So next one, electrical appliances. We'll discuss about electrical appliances. Electrical appliances. Electrical appliances. So now we are going to the next topic, that is electrical appliances. So first one is cell. I'm taking. This is the cell. Positive terminal, negative terminal. Cell. Second one is battery. Battery. Positive terminal, negative terminal. This is the battery. Third one is open switch. Next one is closed switch. Fourth one is closed switch. So fifth one is cell, battery, open switch and closed switch. Okay, next one we are going to the one more, resistor and sixth one, rheostat. Okay, next one, ammeter. Next one, voltmeter. Ninth one, wire joining. 10th one, wire crossing. 11th one, bulb. Okay, so cell, battery, if it is connected in circuit, that will be the open circuit. If it is connected this one, that is a closed circuit. A resistor is a device which is used to oppose electric current in the circuit. The resistor is a device which is used to oppose electric current in the circuit. Rheostat is a device which is used to regulate the current without changing the voltage source. Which is used to regulate the current without changing the voltage source. Okay. Next one here, ammeter, voltmeter. So connecting, wire joining, wire crossing, and a bulb. So ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. Voltmeter is a device which is used to measure the potential difference. Ammeter is connected in series combination. Voltmeter will be connected in parallel combination to the circuit. Okay. So these are the electrical appliances. These are the electrical appliances. Electrical appliances. So now we are going to the next topic, that is circuit, electric circuit. Electric circuit, a continuous and closed path of a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. So I am considering now a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. Okay, so I am considering electric circuit, electric circuit, electric circuit, electric circuit. Electric circuit, I am taking the battery here. Battery, switch, ammeter, bulb. So current is passing through it. Current is passing. So now you can see electric circuit is nothing but a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So here there are 2 points are there. One is conventional current, conventional current, conventional current, and second one is electric current, electric current, electric current. Conventional current is nothing but flow of positive charges will be considered as a conventional current. Flow of positive charges. Flow of positive charges will be considered as a conventional current. Flow of electrons will be considered as electric current. So positive charges will move from positive charges. Okay. So positive charges will move from high potential to low potential. High potential to low potential. First point. Coming to the second point. So negative charges will move. Negative charges will move low potential to high potential. Low potential to high potential. Once again, positive charges will move always from positive terminal to negative terminal. Whereas negative charges means electrons. Electrons will move from negative terminal to positive terminal. Negative terminal to positive terminal. Positive charges will move from high potential to low potential. Okay, the direction of current will be taken as the direction of conventional current. The direction of conventional current will be taken as direction of positive charges. Direction of electric current will be taken as direction of negative charges. Okay, so conventional current is nothing but, so positive charges will move from high potential to low potential. Electric current will move from negative terminal to positive terminal. Negative terminal to positive terminal. So this is about conventional current and electric current. Conventional current and electric current. I hope it is very clear. Conventional current and electric current, right? So next one, we will discuss about electrical potential, potential difference. Related to this one, few questions they will ask. Related to this one, so here once again, conventional current is that what? Positive charges will move from positive terminal to negative terminal. That is a conventional current. So negative electric current will move from negative terminal to positive terminal. Negative terminal to positive terminal. Negative terminal to positive terminal. So positive charges will move from high potential to low potential, whereas negative charges will move from low potential to high potential. Clear? So next one. So related to this one, few questions are there. Will I will give. Those are, what is the SI unit of electric charge? SI unit of electric charge is SI unit of electric charge is coulomb. How much is the charge of an electron? Can charge of less than this value exist? No, charge of an electron is, so on one electron 1.6 into 10 power minus 19 coulomb. Okay, so less than this value does not exist. Only this is fixed one. And how many electrons constitute 1 coulomb of charge? In 1 coulomb of charge, how many electrons are present? So in 1 coulomb, so you can take 6.25 into 10 power 18 electrons. Very, very important. We need to remember these 2 points. Okay. Define electric current and SI unit of electric current is. So electric current is nothing but the rate of flow of charge. The rate of flow of charge is called electric current. SI unit of electric current is ampere. So speed of light is 3 into 10 power 8 meter per second. So what is an ammeter and how it is connected? Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. Ammeter is connected. Ammeter is connected in series combination to the circuit. Ammeter is connected series combination to the circuit, right? So related to electrical appliances, conventional current, and so quantization of charge, everything. What is the relationship between 1 ampere and 1 coulomb? What is the relationship between 1 ampere and 1 coulomb? 1 ampere is defined as, so 1 ampere equal to 1 coulomb per 1 second. So what is the relationship between, 1 ampere and 1 coulomb? Okay, next one. So what is meant by resistance? Resistance already we did. So one more question I will give. That is, an electric source can supply of charge. Charge is given. Charge is given. Charge is given. Okay, so So question I'll give, charge is given, Q equal to 500 coulomb is given, 500 coulomb. And the second one is current is given, current is 25 milliampere, current is 25 ampere. So 25 milliampere. So time we have to find out. So which formula we can use? I equal to Q by T. So this is the formula. I equal to Q by T. So substitute the values here. So here one thing you need to understand one. So here you have to understand one thing. That is so milliampere is given. Milliampere you need to understand. Milliampere equal to 1 milliampere equal to 10 power minus 3 ampere. So 1 microampere equal to 10 power minus 6 ampere. 1 microampere equal to 10 power minus 6 ampere. So very important. Remember these 2 points. So in exam definitely these type of questions will come. Okay. So make sure that you are practicing these two. So charge is given, current is given. We need to find out the time. So I equal to Q by T. We can take 1 milliampere equal to 10 power minus 3. 1 microampere equal to 10 power minus 6. Okay. So just check it once. Next one, we are going to the one more. So related to conventional current and electric current. So one more question here. Current is given, potential difference is given. So time also given. We need to find out the charge. Charge we have to find out. Okay, check once here. Current is given. Current. Current is given. Current equal to 0.2 ampere. And time is given. Time 1 hour. 1 hour is given. Okay. So we need to find out the charge. So how to find out? So time is given, time equal to 1 hour. Okay, current is given, current is 0.2 ampere. Current is 0.2 ampere. Okay, so charge we have to find out. Normal formula is I equal to Q by T. I equal to Q by T. So 1 hour is nothing but 60 minutes. So 60 minutes into 1 minute equal to 60 seconds. 60 into 60, that is 3600 seconds. Okay, 3600 seconds. So you can substitute the values. Current is 0.2 and Q you have to find out, time equal to 3600. So Q equal to how much? What is the Q value? What is the Q value? Answer? Yes, 720 coulomb. So 720. So answer is very good. Okay, next one. One more question. So related to this only, number of electrons we need to find out. Find the number of electrons. Number of electrons. This question is very important to find the number of electrons. Okay, check once. I'll give one more problem. That is, so electron charge given on an electron. An electron 1.6 into 10 power minus 19 coulomb. Okay. Second one is time is given 1 second. Time is given 1 second. And current is given 1 ampere. Current is given 1 ampere. So we need to find out number of electrons. Find out the number of electrons. Question is find out the number of electrons. How to find out number of electrons? We need to find out the number of electrons. That is the question. So we know I equal to Q by T. I equal to Q by T. Q equal to Ne. Q equal to Ne. I equal to Ne by T. Ne by T. N equal to I into T by E. Okay. So already they given charge of an electron. So then how much current is 1 ampere? Time is 1. So 1.6 into 10 power minus 19. If you do this number of electrons, so 6.25 into 10 power 18 electrons will get it. Okay, so this is the answer. Check it once. This is the answer. Right? Yes. So that's the question. Next we are going to the one more. So related to V equal to IR given. Okay, so we'll do that. So I'll ask one question. Name a device that helps to maintain the potential difference. Name a device that will help the maintain the potential difference in circuit, electrical cell. What is meant by potential difference? So work done to bring unit positive charge from one point to another point within the conductor. Would the electrons will move from higher potential to lower potential or vice versa? This question is very, very important. With the electrons will move from high potential to low potential or vice versa? No, electrons will move always from low potential to high potential. Electrons will move always from low potential to high potential. Low potential to high potential. Very important. Okay. Next. So circuit symbols they will give. They will ask to find draw the diagram. What is should the resistance of ammeter will be low or high? Ammeter resistance must be low because it should allow the current to pass inside of the circuit. So ammeter current must be low. Okay. Ammeter resistance must be low. Ammeter resistance must be low. So in order to allow the current inside of the circuit. So what is the resistance of an ideal voltmeter? Resistance of an ideal voltmeter is anyone? Resistance of an ideal voltmeter. Resistance of an ideal voltmeter. Resistance of an ideal voltmeter is resistance of an ideal voltmeter is infinity. Resistance of an ideal voltmeter is infinity. Resistance of an ammeter is 0 or ideal ammeter is 0. Resistance of an ideal ammeter is 0. Resistance of an ideal voltmeter is infinity. Okay. Okay, related to this one, we will so we'll work out questions also. We'll discuss questions also. Question along with the questions, concepts along with the concepts and questions also. We'll discuss both. Okay, done. So we'll go to the next topic. That is, till now I explained about electric current, quantization of charge, electrical appliances, and related to after electrical appliances we discussed a few questions. Next I will explain about the potential difference. I will explain potential difference. I will explain. Potential difference. So what is the potential difference? So point A to point B, we are doing some work. We are doing some work to bring. We are doing some work to bring unit positive charge. We are doing some work to bring unit positive charge from one point to another point within the conductor. We are doing some work. We are doing some work to bring unit positive charge from one point to another point within the conductor is called potential difference. What is the potential difference? Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Potential difference. V equal to W by Q. V equal to W by Q. Work done to bring unit positive charge. Work done to bring Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Within the conductor is called potential difference. Electrical potential. Coming to the electrical potential is nothing but electrical potential. Work done to bring unit positive charge. So I'm taking here, this is the positive charge, this is the infinity. So I'm taking some required field or required point, you can consider this is the required field or required point. Work done to bring unit positive charge from infinity to the required field. Work done to bring unit positive charge from infinity to the required field. Work done to bring unit potential from infinity to the required field is called electrical potential. Potential difference is nothing but okay. Potential means within the conductor. Work done to bring unit positive from one point to another point within the conductor. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. So V equal to W by Q only. V equal to W by Q. So related to this one, we'll do few more questions. Related to this one. Okay. Mhm. So state the relationship between 1 volt and 1 joule. 1 volt and 1 joule. Okay. So normally 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. State the relationship between 1 volt and 1 joule. 1 volt is defined as So 1 volt is equal to 1 joule of work is done to bring 1 coulomb of charge. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. From one point to another point. Okay. So define the SI unit of electrical potential. SI unit of electrical potential is nothing but, so same here. 1 volt is defined as 1 joule of work is done to bring 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called electrical potential. Next one, name the device used to measure the electrical potential difference and state how it is connected. So, voltmeter is used to measure the potential difference. Voltmeter Voltmeter is used to measure the potential difference. Voltmeter is connected in parallel combination. Parallel combination. Voltmeter will be connected in parallel combination to the circuit. Okay. So parallel combination. Next. Two wires of equal length. Okay. So this after explanation of resistance and resistivity will discuss. And Ohm's law also there. Okay. So W by Q V equal to W by QS. I'll write one question. So very simple only. So textbook question only. This is very important. What happens to the conductor when temperature of the conductor? What happens to the resistance? What happens to the resistance of a conductor? What happens to the resistance of the conductor when temperature increases? If temperature increases, automatically resistance also increases. Temperature increases, resistance also increases. So keep in mind, that is very important. Now, this question is very easy. Whatever I am going to write, that question is very easy. How much? How much? How much energy is given to the? How much energy is given to each of coulomb, to each coulomb, each coulomb of charge, each coulomb of charge, each coulomb of charge passing through passing through passing through a 6 volts battery, a 6 volts battery. Now you tell what is the answer. The answer is V equal to 6 volts and Q equal to 1 second 1 coulomb. So how much energy? That is nothing but V equal to W by Q. W equal to V into Q. V equal to how much? 6. Charge 1. So that is the answer. Is it clear? So one more question. Very important. Can you tell this answer? What's the answer to this question? Two marks question. Two minutes time. Yes, answer is correct. How? Here we need to take charge is given, charge is Q equal to 2C, and here we need to take difference. V1 is given 118 volts, V2 is given 128 volts. We have to take final V2 minus V1, 128 minus 118, 10 volts. So V equal to W by Q, W equal to V into Q. V is 10, Q is 2. So 20 joule. Answer is 20 joule. Those who got the answer, very good. So answer is 20 joule. Next. So one more question is 15 is given 3, so that is very easy only. So you can do it, that's fine. So what is the relationship between 1 kilowatt and 1 joule? Can anyone say the answer? Relationship between 1 joule and 1 kilowatt hour and 1 kilowatt hour and 1 joule. 1 joule. Anyone? Mm-hmm. 1 kilowatt hour equal to 3.6 into 10 power 6 joule. Actually, this is there directly in textbook. You can check once. So name the commercial unit of energy. What is the commercial unit of energy? Name the commercial unit of energy. Very, very important. Commercial unit of energy. Commercial unit of energy is kilowatt hour. Commercial unit of energy is kilowatt hour. Okay. Next, we'll go to the next topic. Shall we? Okay. Potential energy is completed. Next one we'll discuss about resistors are connected in series. Resistors are connected in parallel. We'll discuss about resistors are connected in series and resistors are connected in parallel. Resistors are connected in series. Resistors are connected in parallel. Oh, before that, did we discuss Ohm's law? Ohm's law we didn't complete, no? So Ohm's law we have to start. Ohm's law. After that, we will discuss resistors are in series, resistors are in parallel. Ohm's law, Ohm's law, Ohm's law, Ohm's law. So based on Ohm's law, we'll do problems, few problems also. So let's start Ohm's law first. Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. So I am taking here the potential difference across the ends of the given metallic conductor. So I am considering here. So ammeter, The potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. Right? So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at constant temperature. At constant temperature. At constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR, right? Yes. Now we can take materials required. What are the materials required? Materials required. Materials required. First one, we have to take 4 cells, 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. 4 cells, 4 cells, 1.5 volts each. Second one, nichrome wire. We have to take the nichrome wire. Nichrome wire is 0.5 meter. And coming to third one, so 4 cells, 1.5 volts each, nichrome wire, ammeter, and fourth one, voltmeter. So switch, and seventh one, sorry, sixth one, sixth one. Connecting wires. Okay. 4 cells, 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. So ammeter, voltmeter. So materials required: 4 cells, 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Ammeter, voltmeter, switch, and connecting wire. So these are the things. Now we can take procedure. So we have to connect one cell. And note down the reading of ammeter and voltmeter. We have to connect one cell. So we have to connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Connect 3 and 4 cells. 3 and 4. Okay. So first you have to connect one cell. And note down the reading of ammeter and voltmeter. Connect to 2 cells and note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. And mention in the tabular form given below. So I am taking the tabular form here. Serial number So Ohm's law gives the definition of resistance. Ohm's law gives the Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Okay. So 1, 2, 3, 4. 1, 2, 3, 4. So these are the points. Once again, observe carefully. First, Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. Second point is materials required 4 cells, 1.5 volts each, nichrome wire, ammeter, voltmeter switch, connecting wires, and a processor. Processor is first connect one cell and note down the reading of ammeter and voltmeter, ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4 mentioned in the tabular form given below. Okay. Then if you draw the graph for VI, V on y-axis, I on x-axis, the graph is linear for ohmic conductors. The graph is linear for ohmic conductors. For non-ohmic conductor, the graph is curved. V on y-axis, I on x-axis. So if you draw the graph, ohmic conductors. What are the ohmic conductor? The conductor which obey Ohm's law. The conductor which obey Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. The conductor which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Okay, so these are the graphs. Okay, so I hope it is very clear to you all. So this is about Ohm's law. Once check the Ohm's law. So check. Now, so we'll start. So next one, resistors are connected in series. Resistors are connected in parallel. Resistors are connected in Resistors are connected in series combination. Resistors are connected in series combination. So here all resistors are connected in such a way that you can check once. You can check once. I am taking 1. So 2, 3. Throughout the circuit, current is same. Throughout the circuit, current is same. Throughout the circuit, so I am considering here ammeter, ammeter. So here so resistor R2, R3, R3, V3 across. So this R1, R2, R3, current is flowing. Now here you can observe current is flowing, right? So throughout the circuit, current is same. Throughout the circuit, current is same. So IS equal to I1 equal to I2 equal to I3 equal to IS equal to I1 equal to I2 equal to I3 equal to I, because throughout the circuit current is same. 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 Potential difference V equal to IR from Ohm's law. V equal to IR from Ohm's law. V equal to IR. V equal to IR. Okay. So potential difference equal to I into R. Now you can observe Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. Across R1 potential difference V1. Across R2 potential difference V2. Across R3 potential difference is V3. Once again, across R1 potential difference V1, across R2 potential difference V2, across R3 potential difference is V3. Now Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. So now IRS equal to IRS equal to IRS equal to IR1 plus IR2 plus IR3. Shall I take I common? Because I is common in, okay, so in right side and left side, both side, okay. So LHS and RHS2. So I am taking I common, R1 plus R2 plus R3. So I get cancelled. I get cancelled. RS equal to RS equal to RS equal to R1 plus R2 plus R3. So this is about resistors are connected in series combination. Resistors are connected in series combination. Resistors are connected in series combination. Once again you can see. So resistors are connected in series combination. R1, R2, R3 across R1, V1 across R2, V2 across R3, V3. Current is same throughout the circuit. Current is same throughout the circuit. Right? So Vs equal to V1 plus V2 plus V3. IRs equal to IR1 plus IR2 plus IR3. So I am taking common. Rs equal to R1 plus R2 plus R3. If n number of resistors are connected, in series combination, Rs equal to Nr. If n number of resistors are connected in series combination. Okay, so I hope it is very clear. Shall I go to the next one? Resistors are connected in parallel combination. We'll discuss. Resistors are connected in parallel combination. So we'll do that. Resistors are connected in parallel combination. So we'll do this one after the class. So we'll do few more problems. After this at 3 o'clock, around 3:30, not 3, so 3:30. 3:30 we'll do problems. One more concept I'll discuss. So now resistors are connected in parallel combination. 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 So I'm taking now. So this is one resistor, one more and another. So there are three resistors connected in parallel combination. Ammeter and so battery, switch, current is passing. So now across R1, R2, R3, R1, R2 and R3. So across R1, R2, R3 we are connecting potential difference V. Across R1, R2, R3 we are connecting potential difference V. So potential difference V I am connecting. So voltmeter I am connecting. So across R1, R2, R3 potential difference is same. Voltmeter is connected across R1, R2, R3. Okay, so now current is flowing. So current I am considering I. Okay, I is the current. So when the current is flowing through R1, R2, R3, so it's split into three parts. So across R1, I1 I am taking. Across R2, I2 I am taking. across R3, I3 I am taking. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR I am taking. V equal to IR. I equal to V by R. I equal to V by R. V equal to IR. I equal to V by R. V equal to IR. I equal to V by R. Right. Now, here in this case, in the parallel combination, resistors are connected in parallel combination. Resistors are connected in parallel combination. So Vp equal to V1 equal to V2 equal to V3 equal to V. Across R1, R2, R3 potential difference is same. Across R1, R2, R3 potential difference is same. But current is dividing into three parts, I1, I2, I3. Current is dividing into three parts, I1, I2, I3. Now we can consider Vs, no, I. Current we have to take IP. IP equal to I1 plus I2 plus I3. Okay, so V by RP equal to V by R1 plus V by R2 plus V by R3. Okay, so now shall I take V common? So V I am taking common. V I am taking common because potential difference is same. So that's why I am taking V common. So V, if you are taking common, 1 by Rp equal to 1 by V I am taking common 1 by R1 plus 1 by R2 plus 1 by 3. So V will get cancelled. The remaining values are 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So this is about resistors are connected. Resistors are connected in parallel combination formula. If resistors are connected in parallel combination, that is, so V IP equal to I1 plus I2 plus I3, V by RP equal to V by R1 plus V by R2 plus V by R3. So V 1 by RP equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Right? So this about resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay. So related to this one, few problems are there. We'll discuss few problems. Then we'll go to the heating effect of electric current. One more topic is there. So that is factor depends on resistance. Factor depends on resistance. So R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. Okay. So resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to L by A. So R equal to rho into L by A. R equal to rho into L by A. Okay. So now we can see resistivity. Rho is the resistivity. RA by L. SI unit of resistance is ohm. SI unit of area is meter square. SI unit of SI unit SI unit of area is meter square. SI unit of area is meter square. SI unit of length is meter. So ohm meter. Okay. So SI unit of resistivity is ohm meter. Is it clear? So R is directly proportional to L. So R is directly proportional to L, R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A, rho equal to RA by L, right? So ohm meter square by meter, meter get cancelled. The value SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter, very very important. So based on this one, we need to do problems also. Resistance, SI unit of resistance is ohm. SI unit of resistivity is ohm meter. Ohm meter. So resistance depends on length of the conductor and area of the conductor. Resistivity does not depend on length and area. Okay. So resistance depends on temperature and material of the conductor. Resistivity depends on temperature and material of the conductor, right? So these are the points related to resistance and resistivity and Ohm's law. Resistors are connected in series, resistors are connected in parallel, and one more heating effect of electric current is left. Heating effect of electric current. So that we will discuss about at 3:30 p.m. today itself. Today only at 3:30 p.m. you can join to the class. So we will discuss problems on this. Few problems. So at 3:30 p.m. I'll take class regarding the problems. So we'll do problems related to resistors are connected in series, resistors are connected in parallel. Factor depends on resistance and resistivity. Okay, so thank you so much for joining and attending and listening and giving an opportunity to teach the class. Thank you so much.